I'd like to welcome everyone to a presentation jointly of my plenary and breakout sessions from WMSCI 2020, the development and evolution of Agile, and I'm going to go right to the presentation. A wonderful slide. Okay. So this work is joint with Vasilka Karova of Bell Labs Consulting, Garrett Chang of High Step Technology, and Om Hashmi of Agile Brains Consulting, who graciously joined us after the paper was written. So as an overview, we're going to look at what is Agile, the implications for software development. I'm going to look at what allowed Agile to be developed, what it was at the beginning and how it has changed, mostly in detail rather than in concept, and in some places where Agile needs modifications, limitations, and how it responds to that, and finally conclude with more or less a review and a thank you. So there are two major parts to Agile. One is that it is a method of dealing with incompleteness and uncertainty, requirements that are not always known at the beginning, but gradually converge, processes that don't behave as expected, and changes in the world as we're developing. The other half is that it is a robust and disciplined approach to improvement and delivered value in face of that incompleteness and uncertainty. So we plan to deliver partial but value-rich products and services early and often, assess the project ourselves and get reaction from the client and if possible users, and build from there. We rely on properly prepared professionals working in teams with guidelines, practices, tools, and other approaches that have been developed over time, and with appropriate metrics and assessment, and with the idea that everything can be improved upon reflection, looking back at what we've done. Finally, we want to say that Agile should affect not just the development process, but the entire organization, working, as we'll say multiple times in this presentation, onward and upward from the development team into all business processes. So in the software universe, we particularly want to see it as a structured but flexible approach to management, technical, and enterprise facets, beginning with project-driven team and customer-centered view, with early and constant customer involvement, embracing change, self-organizing teams and emergent requirements, and as we've already said, continuous integration and delivery of value. The development structure is short, time-boxed iterations coordinated by a product backlog, as well as by plans, driven by user stories and use cases. Emergent ideas, as we'll see, include clean code, test-driven development, and refactoring. We have a situation-dependent, but generally relaxed view of formality, use notations, use documentation as needed or as necessary for the project, but that doesn't mean that we lack discipline, we lack documentation, or that we lack a contract. So we can look at the Agile world process for software development as following more or less a cycle, though this is one view, and as we'll see, it's not a complete view, delivering to the product, client, and providing for the next iteration, valuing client feedback at the instances that I've indicated by the blue arrows in this diagram was developed by Orion Advisor Technologies. Client feedback is particularly useful as we go on to the next iteration, as we brainstorm early in design, in assessing quality, and in responding to the deployment. Agile thinking has evolved as a worldview and gained an influence. There are a number of established methodologies. It's interacted with the lean and Kanban methods. It's scaled up, and it has interacted with and influenced DevOps, DevSecOps, and so on. As a worldview, it has spread into management and business processes in several sectors, as you see noted, but it needs to be understood and implemented properly and carefully, used where appropriate, modified as needed, and treated as an ongoing living thing, not just a certification, religion, or silver bullet. Okay, given that this conference is a conference on informatics, systemics, and cybernetics, we want to note that Agile does interact well with cybernetics, both first-order cybernetics, since the systems we're developing are generally controllers, code, and the systems they control, and observers and developers, the technical team, the user, and the management with the systems they observe, the application. In each case, cybernetics was intended not just as an academic study, but as a way of affecting design optimization and extension, and identifying and making explicit and effective feedback loops and strategies for improvement. Agile approaches use several techniques to do exactly those two things: affect design optimization and extension, and identify and make explicit and effective feedback loops and strategies for improvement. How did Agile come about? The early computing environment consisted of a small number of developers, scientists, mathematicians, business data processors, trying to implement well-known algorithms, scientific communication, or straightforward processing in a batch environment where the output was going to be largely printout on paper, understood by those experts, so it didn't need a lot of fancy labeling or interpretation. Software development began with stored program computers and higher level languages, although the computers, as you see at the right, were generally pretty large, but on the other hand, by comparison to even today's cell phones, pretty low powered. And this limited capability, the batch environment, the well-understood problems meant that the experts could do very well. Beginning sometime around the late 60s, we see a larger set of users, a use of a larger set of applications. So that creates greater challenges. On the other hand, we start developing more effective programming via data structures and modularity. On the one hand, that allowed bigger and more complex programs, doing more complex things to develop more easily, but allowed for more serious design and implementation errors. On the second hand, and on the third hand, which I've suddenly grown, it allowed for gradual improvement, generalization, and reuse. These were complicated by the development of interactive processing, terminals, and eventually PCs, leading to the internet, graphical user interfaces, games, configurability, user-driven actions, and more. Early software engineering began with these more complex programs, began by analogy with construction of physical plants, process control, hardware design, numerical algorithms, scientific computation, and engineering processes. So it involves sequential phases of requirements, elicitation and acquisition, specification, design, implementation, testing, deployment, and maintenance. The flow of information between phases was fairly clear, but the phases often relied on ad hoc structures, activities, notations, diagrams, and so on, which had been used by scientists, mathematicians, engineers, and developers. So codified formally as software engineering in the late 60s. This is what the waterfall method looked like in principle, with a few of the phases left out. Early failures tended to require restart of the project or project phase. So a failure in code may mean I might have to go back and do the entire design over, or even the entire analysis. And late failures were often fatal. So this led to the idea of why don't we refine the model so we don't get those horrible failures, and enhanced partially incremental but mainly sequential models where the failures in the design of one phase could lead to improvement requirements in the next pass. Failure in the coding in one phase would lead to improvements in the design in the next phase. And I could somewhat have the phases lead to different deliverables. So there were still frequent and serious difficulties in maintaining schedule, budget, quality, and completeness due to the continuing representation gap, due to the fact that we were not modifying the process as we went along, as seen at the right, and due to the difference between incremental and iterative, which we'll address on the next slide. So an incremental method develops pieces, tests for those pieces to see if they've been properly developed, but most often those pieces do not deliver value to the customer. An iterative method, on the other hand, may develop pieces that won't be part of the final product, but can be used by analogy or by extension in the final product. But at least after some very early phase, each iteration should deliver a product that can be used by the customer, or can at least be seen by the customer as converging on a product that can be used, so can be evaluated more easily by the customer. An iterative process should generally be preferred unless the partial products cannot be used, as in, say, implementing a physical chemical manufacturing plant, or have grave risks such as developing a cardiac workstation. The second dimension that led to Agile was the improvements in the infrastructure. On the one hand, improvements in the physical development infrastructure, better programming languages and compilers, better computer architecture, more storage, more power, better development tools, including integrated development environments, which meant that the designers, the coders, could focus on design rather than hand focusing on accessing resources or on the efficiency of individual instructions. On the other hand, this eventually resulted in complications raised by distributed computing, the web, the cloud, the internet, with more multi-programming, multi-processing, multi-core, and the need for a better understanding of it, and the need for development of approaches for graphical user interfaces on the one hand and client-server applications on the other. We also had the development of object-oriented languages, which allowed for encapsulation. Don't put information you don't need in a piece of code, which allowed for code to be reused with modification, specialized when I knew more information, or generalized into patterns, which we'll talk about in a second. Reducing coupling between modules so the pieces talk to one another in highly structured and low-risk ways, and increasing cohesion where one piece of code, one module, one component did one thing, which made it much cleaner, much more reusable, much more easy to understand. Process models were developed for development activities that had low representation gap, so I could develop a model for requirements using use cases that led to fairly clean translation to the class structure, as you'll see at the right, and the sequential communication structure in the design, which then led to fairly straightforward coding, which had to be tuned a bit, granted, but wasn't a complete work from the beginning and figure out what you're doing, which led to fairly straightforward testing and so on. We also got the development of design patterns, which is a catalog of useful idioms, something like compiler optimization, where I said, if you fit this pattern and you're trying to do this thing, here's what you can replace this piece by. Guidelines, heuristics, starting the patterns industry, which eventually included requirements patterns, specification patterns, modeling patterns, design patterns, coding patterns, testing patterns, maintenance patterns, enterprise patterns, management patterns. And I think Dr. Masticola identified somewhere over 1,200 patterns books somewhere in the late 90s. Development approaches then started replacing the classical phases with concurrent workflows. We see here a workflow from an explanation of iterative development. But even so, I could start over increments, saying I do the business modeling and that persists even while I'm doing requirements, which persist even while I'm doing analysis and design, which persists through much of implementation. Everything gets tested as soon as possible. I can even simulate testing requirements way back, but I certainly want to start testing once I have code. And then I can start thinking about how to deploy on through everything. There were not even stresses, but we are stressing each phase all through each workflow, all through each increment, each iteration. However, most of these models still focus to some extent on formal development, artifacts, and documentation. Formal deliverables did not fully address early and late activities and were not fully iterative. This led to some of the same schedule and budget problems as encountered in the waterfall era. Resources, methods, and people would change, but as in the graphic here on the earlier slide, the models, the workforce, and the methods tended not to change. So we wound up with some of the same problems. So roughly about 2000 in a mix of waterfall, incremental, and other object-oriented software engineering approaches. We saw about 1/6 of all projects completed on time and on budget, meaning full quality and full product delivered. About half, a little over half, missing features, missing some quality assurance, late or over budget, and almost 1/3 of all projects either canceled or death march, meaning they were continuing with development even though it was well known that the product would never be useful. This led to the birth of Agile. So in 2001, 17 object-oriented software engineering experts, software practitioners, and thought leaders issued the Agile Manifesto, valuing individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Notice that even here, this did not mean that you did not need processes and tools, documentation, contracts, or plans. Each of them are necessary, but they should not be emphasized to the exclusion or even over the items that are on the left. These 4 value statements led to a dozen process guidelines, principles and guidelines, which are listed, summarized here. Continuous customer interaction, iterations on the scale of a couple of weeks, allowing for changing requirements even late, daily interaction with teams and their management, valuing motivated individuals and teams, giving them full support throughout and trusting them to get the job done, while still, on the other hand, observing how they were doing and interacting with them. Face-to-face as the most efficient, effective method for teams, although obviously that has been modified in the COVID era. Prioritizing simplicity, technical excellence, good design, and aesthetics. Working software as the primary but not only measure of progress. Sponsors, customers, developers, users should be able to maintain a constant pace indefinitely, which does not mean that teams are not due a vacation now and then. At regular intervals, teams should step back, reflect on how to become more effective, reflect on how to tune and adjust behavior, processes, reporting, backlog management, and so on. So these processes are soon codified into agile methods, structured for short iterations, allowing all workflows to be continuous and as much in parallel as we saw in that diagram as possible. Each iteration expected to deliver working code, and products should continuously converge on the product envisioned by the customer and developers. The key features, dynamic as more or less reviewing, but now within the process instead of just principles, dynamic discovery of requirements with customer and expert interaction, definition of requirements and specification through use cases and user stories, fast and continuous delivery of value. De-emphasize formalism except where it's clearly needed or required for reasons such as compliance. But on the other hand, documentation and traceability sufficient to allow the processes to work well. Frequent use of team meetings to monitor progress, define roadblocks, develop a roadmap, that's our planning, manage the backlog, that is what should have been done but wasn't done, what is suggested by what has been done but hasn't been done, what is needed to make what has been done work but hasn't been done. On the other hand, effective use of backlogs to refocus project effort, so figure out what needs to be done first, and to agree with the customer on scope adjustments. We're going to do this and perhaps not that. We're going to do this right away and that later. We may not finish this, we'll reduce this and take a little bit less in payment. Very well suited for a capable cross-functional team responsible for development, a feature or component of a product. As an example, I like to look at 1.3acres.com. Not fully agile, but you'll see its evolution in a graphic at the upper left. If you look at the site, it's a coronavirus tracking software developed by Chinese and Chinese American graduate students in the US. Initially in English and Chinese, tracked the US, China, and the world, with US cases and deaths by state. In quick iterations, it's added more languages, more countries, more visualizations, more analysis, more commentary. It has given rise to a conference paper, and now I think it's a journal article is in process. The main difference is it is probably multiple teams coordinating, but no management, officially at least, no customer, it's crowdfunded, and things happen when they happen, and it's partially open software, at least within the team. DevOps is a creation that has borrowed from and is complementary to Agile development, coming to fruition after the Agile revolution. Developed initially to enable process improvements in IT organizations, spread to development organizations as a whole, creating uniform approach for rapid delivery of high quality software features and solutions to the enterprise markets and customers, and together enabling external collaboration, partnerships, creation of value networks, and development without necessarily having customers ahead of time. So now we're at the point where Agile exists as a method. What has happened since? Well, the first thing is that various groups took to the Agile methodology in various ways. Some just adopted the buzzwords, kept on more or less as they were going, labeled their processes as iterations, their products as deliverables, and what they had failed to do as backlogs, but not much else, and such enterprises often failed, or else transformed themselves into real Agile enterprises. Others have gone overboard, treating Agile as a religion, always emphasizing short iterations even when they were not appropriate, using the practices without any adaptation to the situation, slighting early efforts, as we'll talk about, slighting late efforts, as we'll talk about, and making reflection largely a formal and not a actual intellectual activity. They realized only part of the benefits. Some of them continue to work, but they often need to bring in people to make them fully agile. Others have interpreted it as a silver bullet for development, but not worked on and up, as we'll continue to emphasize. And on the other hand, some have gone overboard, totally overboard, saying, well, I prioritize people over processes. It means I can be very loose with regard to processes and so on. And in particular, meaning that contracts don't matter. If you can sell your customer on that, you wind up with an ill-focused and ill-controlled issue, or you wind up with too little flexibility because the contract doesn't give you an agile aware view that says we'll discuss, we'll have deliverables at these dates, and we'll look at what deliverable needs to be done from there. Okay, in particular, I want to focus this on the early and late activities. As we said, not all requirements are suitable for continuous discovery, a problem with some of the groups that have tended to go overboard on Agile. You cannot necessarily view security, safety, timeliness, physical building issues as discoverable as you go along. Security has to be understood almost entirely at the beginning. You cannot make all those decisions during iterations, although early iterations need not develop the full security. It has to leave hooks for security. If an early product is to be delivered, as we'll say later, in a time-boxed view, sandboxed view, then I may not need to provide all the access control I will once I go to, say, beta testing. And not all architectural decisions, separation of modules, interfaces with modules, as we'll also say later, can be made during iterations. So they'll be made in what has come to be known as iteration 0, the architectural runway, or the length of that runway and the separation from the first iteration will depend on enterprise culture, familiarity of the domain, the nature of the application, and how much it stresses those non-functional requirements. At the other end, there's a danger that I can make all of maintenance into dealing with the next iteration, with brainstorming in the next iteration, and that doesn't work either. I have to be able to quickly debug obvious mistakes in the release. I have to be able to assist users in issues with help and manual. I have to be able to make quick security patches, and I want to get some information out of the execution of the current version that is going to mean that we have to continue to monitor that version, profile, do history tracking, On the other hand, management can completely misunderstand Agile. It can assume that good people and tools automatically result in good development without the costly and time-consuming training and team development before I even begin iteration 0. At the other end, often organizations tend to say, well, things are going pretty well. We're getting pretty high quality software. The teams are happy. The technical management is happy. The customers are happy. And it takes time to do all those retrospectives. Let's not worry. So what do we need to do in the runway? First thing we need to do is decide whether we should be doing this at all. Is it feasible for us? Does it fit our business model? Should we trust this client or, on the other hand, this developer? Are we going to have time? Do we have too much other work? Do we have the resources? If not, can we find them? And are they within budget? So should I get started? Once I decide I should get started, let's look at those non-functional requirements and look at other requirements that we know aren't going to change and look at requirements such as the physical building or plant, or the assembly line and process control line I'm going to have to use, and let's see what we need to fix out of those. Let's figure out what assessment tools we need. We need to go beyond working software and the concomitant code reviews and demos and reflection into things like various ways of testing test coverage itself, testing how many bugs we find and how many we're likely to find, trying to address serious failures, trying to identify causes of failure, and so on. We should not expect the team, as we've talked about on the last slide, to learn new domains, types of applications, language features, tools, practices, or types of, as we said, non-functional requirements on the fly. So we do need to supply training, coaching, support, both at the beginning and ongoing expert consulting for teams and for technical management and organizational management. Model core practice says focus and limit your use of diagrams, system, and notations. Use the formality you need during design, development, analysis, and design, and if necessary, make them formal later. Separation of concerns into interfaces, business logic, technical support. Use of patterns and anti-patterns. Anti-patterns are things that often happen, and here's how you should deal with them. And anti-patterns are things where you're tempted to deal with common problems, and this isn't the way to do it. Refactoring, which is, as I said, the analogy of code optimization. Here's something that we're doing. Here's a way that it either is bad or has gotten bad as we have allowed it to develop without fixing it, without tuning it. And here's a way to take it and replace it by locally, by new code, new analysis, and code that tends to replace it by something that works better, is more elegant, is cleaner, driven generally by code smells, things that have happened to the code and have made it less clean, less useful, or technical debt. It's been a long time since I've looked at this piece and I have problems with it. And a use of various tools, including source control systems, test automation frameworks, interface testing, static analyzers, continuous code integration, and better integrated development environments. Okay. Component, service, or microservice development based architectures, full stack development, user interface, business logic, data interfaces, service interfaces. Incorporation of aspects, something that when I started looking was not a major practice. In fact, it was thought that this would be very difficult to fit into object-oriented development and into Agile. And now has become very common to handle cross-cutting concerns such as logging, security, access control, and many other things that are in some sense orthogonal to the business logic, but occur all across the implementation. It's also true that when Agile started, almost everything was object-oriented development, but we have come to see that functional language features can be very useful. Functional languages such as Kotlin and Scala are now being used, particularly in the user interface aspects, and even languages like Java provide features such as Lambda expressions. There's also been, following Uncle Bob Martin's clean code, an emphasis on smaller, even more cohesive classes and methods, with even more restrictions on dependencies, modes that allow very low coupling, or idiomatic situations such as the relationship of a container, such as an an array to its members or a list to its members, and complementary to the use of aspects to factor out these cross-cutting concerns that tend to clutter code. These are especially used in highly used, that is over and over executed, critical, high-risk, frequently modified code segments, which Craig Larman identifies as points of protected variation. Also, a greater emphasis on explicit consideration of concurrency throughout the process, beginning, in fact, in analysis, when the use of diagrams such as activity diagrams explicitly allow for concurrency, into design, programming, testing, where the testing actually is significantly complicated by the fact that things don't necessarily occur in a prescribed order. All of these and other changes may reorder our tasks, say that things that used to belong in one iteration now should be deferred, things that, or on the other hand, brought forward, things that need to be done early in an iteration now can have to wait until I've, say, implemented aspects properly, or reprioritize the backlogs. I look and I say, okay, this is what I thought I was going to need to do next. Maybe I need to do this next because I've identified a code smell or for some other reason. Okay. For corporate management, and I'm sorry that the only figure I could look at first, or the only suitable figure I could look at first, as a male manager, whereas in fact one of the 3 co-authors on this paper is a female manager who does very, very well. Okay, corporate and technical management must care for teams, incorporate Agile onward and upward, identify dedicated product owners who will keep oversight of the overall process of a project, match product backlogs to emerging and original requirements, coordinate client interaction. You don't want a client who has to interface with multiple teams. I'll say that again. Keep track of progress and use of resources. Make sure that the resources you have, including personnel, are adequate to the rest of the project. And again, upward and outward. Okay, these processes will scale up to whole organizations, whole projects, including multiple products and product lines, and will interact more with DevOps and marketing, operations, vendor management, customer support, and so on. Okay, finally, before we get into these modifications, I'd like to look at Agile as an aesthetic approach. A principle of modern software engineering is good code is beautiful code. It provides a much better working environment for the developers who can see more clearly what is going on because things are elegant, and it provides a pleasing and natural interface and experience for users. Has been facilitated by some of the changes we identified earlier and by process changes that, among other things, emphasize aspects, emphasize reuse, emphasize short methods, emphasize future use rather than just getting the current process right, together with refactoring, which says if anything has gotten ugly, let's reduce that uglification as the program changes over time. And many of the modern developments result in much more comprehensible, much more cohesive, much more cleanly separated, and much more elegant code. So now that I've looked at what Agile is, and what Agile can do, let's look at what it has difficulty in doing. The first thing, of course, as we've said a couple of times already, critical non-functional constraints and constraints well known at the beginning may require some modification. Privacy, security, accessibility, timeliness, safety, external interaction with the cyber-physical systems may require changes. For COVID-19, you can look at a test processing system, which has to wait until it has a minimal number of false positives and false negatives, has to deliver a visualization that is usable, and has to coordinate, modifying ICU workstations to work with COVID-19 patients. The software has to wait till the hardware is in place, and it has to make sure it delivers the appropriate messages you do not want to deliver. Very many, you'd like to totally minimize the false positives, and you'd like, as far as possible, to eliminate the false negatives. You want to get that help to someone who is having a serious and immediate problem. Monitoring air quality, same problems. And health information, as I'll talk about later, I have the tracking versus privacy issue. Now I want to look at limitations on their use, product size and complexity, development structure for large projects, nature of the application, requirements, formality, and consultation, or the need for high creativity, novelty, innovation. Each of these requires somewhat different modifications. Large monolithic components mean often that I have to deal with software architecture approaches that with a high level decomposition and stable interfaces, possibly with different groups working on them, but chunking the development so I don't have to worry about modifying everything everywhere. Stable interfaces may be modifiable to a limited extent. One of our early WMSCI papers dealt with that. Agile development does well with transactional and other data-rich systems, on the other hand, but some data issues need to be addressed in advance, and in particular, data collection and data cleaning have to generally precede or largely precede time-boxed iterations and cannot be put aside because they will result in useless or possibly even incomprehensible results from data analyses. On the other hand, outside of some of these iteration zero activities, and outside of what is necessary at the software architecture level, uses of microservices, containers, design patterns, and for that matter, full stack development somewhat mitigate this problem by facilitating decomposition, development, deployment, resulting in bounded context cohesive services. Large projects, sort of complementary to this issue. The problem is that we may have a single piece to develop, but that piece may be big enough to require multiple teams distributed across multiple sites or as a particular problem in different business entities. And again, we probably need to deal with some sort of high-level decomposition. We also need to deal with customer contact. We, as we said earlier, don't particularly want the customer to have to deal with 50 different teams, and we don't want to have 50 different teams have to be in day-to-day communication. So the first problem has been largely resolved by larger scale frameworks such as LESS and by the software architecture issues that we talked about a few slides ago. We have to deal with inter-team communication by virtual meetings and occasional visits, particularly across ventures. Customer contact by identifying a customer advocate, often the custom product owner or a single designee or possibly a few designees. We do not, as we said, want to have 50 teams talking to 20 customers. Sometimes that will happen. But the customer advocate will serve as a channel, keep the focus on the product rather than the development itself, identify situations requiring others to participate in the discussion, and bring in particular customers or customer representatives or specialists on the one hand, and team members or technical managers on the other, to discuss particular problems with particular components. For COVID-19, international collaboration on software for monitoring problems and triggering safeguards has had to deal with establishing interfaces for exchanging information, for establishing how that information would be exchanged, for dealing with what component would do what team would do what, and so on. So here's a snapshot, I'm not going to deal with it, of Craig Larman's LESS framework that shows you how multiple products, multiple related products can be dealt with in the Scrum framework. It does not include the interaction explicitly with the customer, but otherwise it gives you a good view of how multiple products in a single product line or related product lines can be dealt with. Okay, a third issue is the nature of the application. And as we said, there are three problems. The first is applications where I understand most of the requirements very well. Second, applications that have physical components that have to be dealt with, where some of the requirements have to deal with how those physical components, which could even be large buildings, have to be built, and so cannot, again, rearrange things at very high level and say, well, let's move this around or let's change the order in which things are done without a lot of adjustment. So how much adjustment is allowed is constrained. The third is protocols, where almost all of it has to be working perfectly for it to work at all. So in those cases, Agile will tend to be focused on user interface, user experience, visualization, the sort of bookkeeping, tracking, and auxiliary services that are offered by aspects, rather than on implementing any of those in particular. A fourth issue is that some applications will require a higher level of compliance, a higher level of documentation, more formality. Formality has to be, documentation, compliance, and formality will have to be used in addressing all of these tight non-functional constraints or significant timing constraints or cyber-physical systems. There may also be legal, regulatory, or standards requirements, or for the requirements for the use of particular methods not entirely agile in particular domains. In Europe, for instance, safety-specific real-time applications for a long time had to use formal methods. I don't know if that's any more true. In many European and in other international applications, the application has to comply with requirements for interoperability and internationalization. Other projects may require specific approvals at specific points, for example, for that internationalization and interoperability for safety or whatever. So experts have to be consulted in addition to the customer. Finally, some customers may require formality to establish priority for legal reasons, trademarks, patents, or indicating that they have not interfered with someone else's patent, and so on. Finally, Agile development seems best suited for a moderate degree of uncertainty about the feasibility of solutions rather than radical innovation. It's not intended to handle radical innovation or speculative exploration, where I need a major discovery, aesthetic novelty, innovation, or I need a new algorithm, data structure, or visualization that I don't already have a good idea about, or in data science explorations that require patent discovery on a large data set using artificial intelligence or data mining. This particular bullet reminds me of the situation in a bureaucratically run university where all researchers were required to explain what they were going to be doing this semester. And a mathematical researcher required that he would, responded that he would prove two new theorems, find a counterexample, develop a good explanation for this particular framework, and internationalize this product, which of course is ridiculous. You can't simply know what direction your research is going to go in, what theorems you're going to be able to prove, where you're going to find a counterexample, and so on. And such explorations, as we just said, through that analogy that the goal or the goal path is open or fuzzy, so time boxing is inappropriate or possibly even impossible. Backlogs may be hard to identify. I know I need to finish this proof, but I don't know what I need to do. Rapid or continuous delivery of partial solutions may not be possible, or the partial solutions may not be meaningful. So we need to look for a cross between Agile and team processes, and some alternatives do exist. So for the COVID-19 examples, modified infection models, I know what I have to do, but I don't know what's going to work. So I can try things. Reporting things that don't work isn't going to help. Reporting things that work a little bit may or may not help, depending on whether they seem to be headed in the right direction. As another example, consider the ad campaign for vaccine promotion. The aesthetics and the innovation have to be sufficient, so it will actually persuade people to use the vaccine. A partially developed product that will actually discourage people or tend to make them distrust future releases is not a good idea. There do exist hybrid approaches combining agile and sequential processes aimed at large system developments, industrial applications with physical components, as we said before, or where I feel I need where I have a greater need for requirements engineering early in the process to get things down on paper, down in documentation before I start. These are particularly useful in some cases for Internet of Things, because testing and dealing with non-determinism has both the physical issues and the issues, the physical security systems and non-determinacy, leading to an enhanced hybrid or modified methodology. Nonetheless, with every one of these and in management, Agile tends to remain appropriate for development of individual components, particularly for user interfaces, connections to services, and some of the aspects such as we said, tracking, access control, and the like. Some guidelines, as you can see below, remain good practice. Do continue to talk to the client and describe what has happened. If you can't display a partial product, do display a prototype. Do interact on the user interface, non-behavior. Do have frequent team meetings. Do develop backups for key team figures and figures in technical management. Use test-driven development throughout. If you have to, simulate events, mock physical devices, rather than leaving them completely untested. In some cases, as we've said, you may not be able to fully test physical devices. I do not want to create heart attacks to test my cardiac workstation, but I do want to know that I am responding properly to a mock of a heart attack. Identify critical and core components and prioritize backlogs. In some cases, as with innovation, that prioritization can only be partial and may not work in the long run, but it's still useful. Here are 3 directions I think I can pursue in making this proof. Finally, I want to look at a few business and process enablers. I've already seen most of this on other slides. A key point is to encourage individual and team growth, even at the risk of individuals leaving the team, leaving the enterprise, and that growth should include knowledge and capabilities orthogonal to the current product. Incorporate Agile all the way up. On the other hand, do maintain oversight. Okay. We need to build an Agile culture all the way through. Make sure Agile managers and technical leaders understand agility, serve as advocates, and are willing to argue for the benefit of early and late processes, and of reflection, and of improvement via refactoring and other approaches. Okay, technical and corporate management have to understand some of the processes, team dynamics, indicators of processes, the metrics that are being used, and how backlogs are being used, and how the negotiation or interaction with the customer occurs. Customer has to be open to contact, alert to changes, willing to accept deliverables, willing to share information and provide feedback on those, willing to share information on the customer's perception of changes in the marketplace, comfortable with a contract that accepts some late decisions, and should ordinarily not interfere with detailed design or implementation. There is a problem in that often, well, some products are developed without customers. The customer might not be the end user. And even when I have a customer, that customer need not be the actual person to whom I'm selling the product, but rather a management representative. And the other problem is the customer, even if I have one, and even if the customer is willing to interact, may not be the expert on the product. So if any of those is the case, we need to have customer contact as close to the client and end users as possible. We may need to have some representatives for the client and end user, possibly not named by those individuals, but somebody we feel can represent that community. And we need to place greater use on alpha testing with trusted users, beta testing with a more or less random selection of users, and acceptance testing with the eventual customers. Management has to agree that Agile methods are appropriate for the project, product line, set of products under consideration. But on the other hand, at a very local level within individual teams, it can allow a team to use a different methodology. Google now does so, although the interfaces have to be as if the interfaces are dictated by software architecture, and Agile is occurring at all teams. Okay. And processes have to be preserved no matter what teams are using. Frequent testing, test-driven development, configuration management, reflection, and iteration. Okay, in conclusion, this is what we've done, and in the future, we'd like to look a little bit more at some of the holes we left for the limitations of pages and time, and also the use of Agile in other domains, including 4.0 industries. And we'd like to look at other facets of business that are using Agile. I'd like to thank all of these individuals, Dr. Stephen Masticola, Dr. Kaios and Dr. Scholl of this conference, Father Larissy, Joshua Chappell of Seton Hall, Dr. Churinka and Joe Prezama, who did a coordinated presentation on DevOps, Dr. Herbert of Montclair State, who provided some input and a lot of support, MAP, who gave us the insight to relate this to aesthetics, and our anonymous reviewers. Thank you very much. For questions, please annotate this presentation or send them to Dr. Thomas Marlowe, thomas.marlowe@shu.edu. Thank you. Okay. Okay, I'm the only presenter. Okay, and now stop recording.